So these are the fundamental organometallic reactions that we need to know. The first is ligand dissociation. So this is basically where the ligand dissociates, leaving a vacant site for the substrate, and is often the first step in catalysis. So, for example, this one, it should be a phosphorus. So PH3 or PME3 is readily displaced. So if you use heat or H3, so the complex that's going to arise is just an empty site. Like this. So the so the electron difference is -2 electrons. There's a loss of one ligand. The oxidation state stays the same. This is obviously an L-type ligand, so the oxidation will stay the same. If it's an X-type ligand, which is not normal, it will go down. And the coordination number is -1 as it goes from 5 to 4. The next is beta hydration, which is the transfer of an alpha hydride, of a hydride in the alpha position of a ligand to the metal center. Transfer. Which produces a carbene. This process is quite rare because of the ring strain. It causes the hydrogen to become too close to the metal, so therefore beta elimination is more probable. So ring strain. And as I said before, the complex forms of carbene, which vary in stability and are probably decomposed. So the mechanism, we've got an alpha carbon and a beta carbon, and we have a lone pair on the metal. This gives it to the hydrogen, and then the bond is broken there, which forms the carbene, which is an L or X2 type donor, which is 2 electrons. So the methyl stays in place there. We now have 1 hydrogen. So the changes of this, the valence electrons are +2. The oxidation state is 0 or +2 because of this L or X2. So if you're considering it an X2, it'll be a +2, or if you're treating it as an L, it will be 0. And the coordination number is +1. -1. Julie, that's 1, 2, 3, 4. Yeah. Oh, yeah, +1, because 1, 1, 2, sorry. The next is beta hydride elimination, which I've said before is more probable. And this is basically where an alkyl group bonded to a metal center is converted to a hydride in an alkene. Goes to its corresponding hydride and alkene. So they provide a decomposition pathway and this is because it loses hydrogen, the volatile gas, which gives a low activation energy route due to close proximity of the beta hydride to the metal. So The mechanism is pretty much the same. We've kind of got a hydrogen bonding here. So what happens is that bond is broken and that bond is broken, which forms the alkene, and then the hydrogen is added on to it. So the valence electrons are +2, as this donates another electron and this donates another electron. The oxidation state is the same, and the coordination number is +1.